Good morning, good evening, good afternoon, and welcome back to INE's series of online classes. In this week, we're going to have one of the CCNP security courses, mainly the implementing Cisco Edge network security solutions. So, a quick introduction of myself for those of you who never met me in person or in any online or on-site classes or at all, have no idea about who I am. My name is Christian Matei. I am a double CCIE routing and switching and security. I have other certifications as well, but not relevant for the scope of this class. I've been on INE for like the last, I actually never forgot the years number, 6, 7 years or something. So you can contact me at the email address cmatei@ine.com or on Twitter or on LinkedIn. So if you have any kind of, let's say, questions about any of the classes, which you've been like a student in any of my classes, anything was unclear, you want to clarify something up, you have any ideas on, let's say, other technologies or other classes you would want to see online or INE taught by myself, then of course I welcome you to email me, contact me on Twitter, or contact me on of course on LinkedIn, on Twitter, just follow. So contact me by any means and let me know what's up. It's going to be a mix of technology discussion, which means PowerPoint slides. Being an online class, we use PowerPoint slides, but ideally on on-site classes, we don't use PowerPoint slides. But being online, we give you some information back and forth in a PDF format. And then we're going to go to pretty much whatever we're going to discuss about each technology. Ideally, we're going to go to the command line or the GUI part and do hands-on examples of configuration, and sometimes, of course, also with troubleshooting of those technologies. Technology discussion is going to be slides, as I stated, whiteboarding, a lot of drawing from my side, and online references, pretty much Cisco documents or vendor independent documents, or maybe Cisco pitch books I would reference back and forth, or any kind of Cisco presentations in there. Then hands-on examples is going to be live examples on real equipment. There's going to be no virtualization, just physical equipment. Of course, we're going to run some virtualization for the Windows devices, but otherwise the networking devices are going to be all physical. As I said, nothing is pre-tested, troubleshooting may be required. So that's and I highly recommend you that if something breaks in class, I've seen like also in on-site classes that a lot of people when something breaks, they just go out to have a snack, have a break, have a coffee. If something breaks in class, I highly recommend you to stay connected in there, because you're going to be able to see what is my approach to troubleshoot a problem, and you're going to be able to see what is my mindset, how do I approach a problem, and then how do I find a problem, how do I fix it in the end, which I think that's a good added value for you in there. So you should ideally stay connected, not run away to have a coffee because something doesn't break, so it doesn't look interesting. Because in the end, and I'm speaking in here about those of you who out there want to become experts in one day. So configuration-wise, pretty much a lot of engineers know how to do things. Some of them know how to do it correctly, some of them incorrectly, but pretty much, we have a lot of documentation available out on the internet. So pretty much a lot of engineers should be able to do a basic configuration of a lot of technologies. But very few of us actually know how to troubleshoot a problem, because that requires a deep understanding of the technologies, and then of course being experienced as well, and having a fundamental good approach to troubleshooting. So ideally, if you aim to become an expert, then you need to have a very good understanding of the technologies, then be experienced on the technologies, and then just build some strategy on troubleshooting, and pretty much that's it, because that's troubleshooting. Knowing the technologies and having a strategy, and that's it. There's nothing special about it. Now, course prerequisites. So ideally, to be able to get the most out of this class, you should have working knowledge of the technologies as below. So knowledge of working with the iOS operating system, basic knowledge of the Windows operating system. We're going to run some tools back and forth on a Windows device. And ideally, you're going to be CCNA RNS certified, or of course equivalent knowledge. So I expected to know what are the OC, TCP/IP layers, what is Ethernet, what are switches, routers, servers, and what are their basic functionalities. What is a switch supposed to do? How is it supposed to do it? What is a router supposed to do? And how is it supposed to do it? Servers and so on. And of course, because this is a security class, you need as well basic knowledge of security technologies. Like first of all, some working knowledge of the ASA file operating system, like command syntax, what are the options, what are the, let's say, how is the ASA code built, what are the features in there and functionalities. And then of course, ideally CCNA security certified or equivalent knowledge, which means I expect you to be aware of firewalls in general, basic, let's say, knowledge. What is NAT? How does it work? What does it do? Access list, stateful firewalls. So those kind of things are, let's say, requirements to be able to get the most out of this class. But of course, since you're live in class, and assuming, let's say, you're not at appropriate level, or maybe it may happen that I speak about a more of an advanced topic, and it's not clear to you, then of course ask questions. And I want to make sure I'm going to clarify, or fill in the gap that you had, which made you not understand what I was saying for that specific topic. Intended audience, of course, everybody, but in general, ideally, people that want to get CCNP security certified, obviously, everyday and entry or intermediate level engineers. So this class is going to help you like get your feet wet in the world of security, and of course on the security technologies which are contained within this course. And then ideally you're going to be able to use that knowledge into real world implementations. And since I'm speaking in here, I want to emphasize something which I forgot to state in other classes. Like at CCNA and CCNP and even in CCIE, we learn about technologies at different levels, and we learn to implement technologies and to troubleshoot them. But we don't learn when to use them and why to use them, which that's network design. So what I'm trying to say in here that, of course, we're going to speak about a lot of technologies in this class as well. But you have to make sure that you use each technology in general for the scope that it was, invented to begin with. You don't use that technology as a workaround for other scopes, because that's not a good approach design-wise, implementation-wise. It doesn't scale, and it doesn't, at some point it's going to break, it's not going to work, it's not going to be reliable. Focus is understanding the technologies. So I'm going to speak a bit later about this as well. But what has to be clear to each one of you out there is that this class doesn't make you certified, and this class doesn't actually, as I'm going to speak in a couple of minutes later, there is no one thing like a class or a book which can get you certified. It's a lot more that you have to do on yourself to get you certified. So my role in here in this class in general at INE is to make sure that we teach you what is the scope of a technology, how do they work, and then how do we implement them, and of course sometimes how do we troubleshoot them. And of course you're gonna see me constantly also teaching you how to properly learn the technologies and not learn commands or memorize commands. So the focus is just to understand the technologies, because if you understand the technology, you're going to get certified to whatever level you want. And if you understand the technology, you're going to know in which case to use the technology and why. Like for example, if you read the CISCO documentation for a document on the internet which is about whatever technology, let's speak about I don't know, ASA, for example, TCP state bypass, right? Which is a feature on the ASA which allows the ASA firewall to close its eyes for some TCP sessions to no longer do stateful inspections for TCP sessions. And now the example that they give in there when they define this feature, which it's correct clearly, is that it is used in asymmetric routing on the ASA. That's a correct statement indeed. But what I would like you not to do is not to close your, let's say, your knowledge on the fact that TCP state bypass is used only in asymmetric routing. So I don't want you to make a one-to-one binding into, okay, the technology is TCP state bypass and CISCO states is going to be used in asymmetric routing cases and that's it. No, because if you just pay more attention and struggle a bit more to learn the technology, and if you just understand what the TCP state bypass does, which is, as I stated, ASA closed at its highest on some TCP sessions, no longer does stateful inspections for those TCP sessions, it means you're going to know in which other, let's say, use cases you need this capability. But if you just rush it and you just read that document and you make a one-to-one binding between, okay, this feature is only asymmetric routing, then that's not knowledge. Because knowledge is knowing how something works. Why do we need it? And then you're gonna know in which cases to apply it, which is not only one use case. But of course, CISCO has to give you a reason, at least one reason of why a technology was invented. But it doesn't mean that's the only reason. So just focus on the technologies in general to learn them properly inside out deeply, and then you're going to know which one to use it, when, and why. And that's what matters in the end. So the scope of the class is I studied understanding the technologies. So ideally you should get certified CCNP security as a result of being knowledgeable, not as a result of memorizing some commands or some technologies and going and hopefully passing the exams. So course scope, as I said before, is we help you pass the exam to get certified, but we don't give you the exam. It's impossible. And as I said before, there is no one single resource, book, video series, whatever, that can get you certified. If you go to a vendor that tells you, okay, come to us and we're going to get you certified from 0 to 100 in 1 week by taking our course, that's a big lie. It's impossible. Because learning means it's a lot more than one class video watching. You have to do a lot of reading, a lot of understanding, a lot of practicing on yourself, and then go and hopefully pass the exam. So ideally, you're gonna understand how things work. Why do they work in a certain way? By doing a lot of reading, video watching. Then you do a lot of practice to actually enforce that knowledge to see it with your own eyes. Then you have some experience with those technologies, and then you're ready to get certified. So as you can see, video series is just one small step in that more complex, let's say, step-by-step approach to get you certified the proper way. And as I stated, also in class I'm going to provide you with some guidance to a structural learning methodology. You're going to see me constantly making let's say, one-to-one mappings between the technology functionality and the technology commands. So as I stated throughout all of my classes, ideally you should learn the technology, have a high-level overview of the building blocks that make that technology works. How those building blocks are connected in between. What is the connection between those blocks? Like what is step 1, step 2, step 3, step 4? What does each step do? And then you map those steps to the configuration part, or the command template. And in most cases, it is going to make sense, the command template, if you understood the technology and the steps to build it up. So this is going to be amazingly good in the end for you out there, because you don't have to memorize commands, you don't have to remember them, you just know them. Because it's easier for our brains to just understand something meaningful, like what is OSPF, why do I need it, how do I use it, how does it work, than actually learning commands. So if you map the technology steps to commands, then it's easier. You're going to remember the commands just by knowing the technology, not because you memorize the commands. So command memorization doesn't stick with you long term, and it's not knowledge. You're not gonna become a, let's say, good engineer in the end. So move away from the command memorization concept. Learn the knowledge is not commands, and to gain knowledge is no shortcut. So what I'm trying to say in here is that, for example, they state that for each of the CCNP, let's say, classes, pretty much you should spend above like 50 hours plus of studying, like reading, and 30-40 hours plus of practicing. And of course, that depends on what is your initial level of understanding of those technologies. So it may differ between each of you out there because you start from different, let's say, levels when you start learning. But regardless of that, you shouldn't base your learning approach on, okay, Cisco said it or vendor said it or statistics are saying that I have to learn about 50 hours of do about 50 hours of reading and 30 hours of practicing. Just stay in there till you understand it. So don't move on from a topic until you understood it, because that's knowledge. So that's how you should actually learn in the end. So that's what I meant by the fact that it's no shortcut. Don't try to shortcut, because on the long term it's gonna be painful for you, because you're gonna be building gaps, not knowledge. So this class is part of the CCNP security track, which is Cisco's intermediate level certification on the security track. In per Cisco description, CCNP is not anything else but a certification which proves that you're being able to configure, implement, support, and troubleshoot most of the Cisco security technologies. Of course, not at a beginner level, not at a advanced level, but at an intermediate level of understanding of the technologies. Now, what is the Sense class? As you're going to see, it's focused mainly on threat defense. We're going to describe threat defense architectures, implement solutions to fix problems to defend our networks, and then we're going to take also a look at some management and monitoring tools available as threat defense. But of course, it doesn't cover all threat defense aspects. This course is targeted primarily on the network perimeter edge, which means the edge of your network. So what are the possible, let's say, attacks, and how do we prevent those attacks? How do we defend the network from those attacks at the edge layer? Where edge is going to be your access layer, we have all of your user devices connected, and the internet or the WAN layer, edge layer, where we have usually firewalls to control traffic back and forth between the untrusted zone, which is the internet or the WAN, and the, let's say, pseudo-trusted zone, which is the inside your internal network, to call it that way. And also, it's focused on infrastructure protection, which means to secure the control plane and the management plane of the networking devices. Course is based on the actual official blueprint from Cisco. I'm going to take in a couple of seconds a detailed look on the blueprint. So let me open up the blueprint. There we go. So you have a couple of sections in here, like they speak about threat defense, where it's primarily the implement firewall part on both the ASA and iOS. So the firewall functionality of the ASA firewall and the iOS routers, pretty much. Then we have the layer 2 security part, which is part of the data plane protection. So what are the possible layer 2 attacks? And of course, what are the solutions in there? Now, if you look in the blueprint, when they state, for example, configure, it means that for the exam, ideally you should know, of course, how to, not only what is the scope of that technology and how does it work, but how to configure it. So in the exam, they may give you a simulation to configure DHCP snooping. While if they state describe, it means that, technically speaking, per the statement, it means that in the exam you should not get configuration of dynamic ARP inspection, but you can get dynamic ARP inspection questions, which means you need to know how does it work and what is the scope of dynamic ARP inspection. Let's speak also about a couple of best practices, which is under the hardening devices part of the class. Then they speak about the management We're going to speak, as I said, about management via ASDM, via CLI, via Cisco Prime, via CSM, just some overview in there about those tools. Then I speak about the management plane, pretty much, of the Cisco devices. We're going to speak about NetFlow, CCNP version 3, NTP, syslog. Then you have for the exam, you have another section which is troubleshooting and monitoring and reporting tools, which means you should know how to use the packet tracer function of DSA, both from the ASDM and the GUI, the packet capture function, and of course to be able to interpret logging messages. If you see a log message, you should be able to interpret what that log message states. And then we have the architecture part, threat defense architectures, where it's mostly talking about how can you deploy firewalls, in which ways, what routed mode, transparent mode, security context, high availability. And then we speak about some layer 2 security solutions, which we're going to speak about as well. Like, it's pretty much the same thing as we saw before: ARP inspection, STP inspections, DHCP snooping. So it's kind of like a bit of an overlap to the initial part, but they focus in here not on the implementation part, but on the, let's say, architecturing part of the network. And then finally, the last subject is going to be pretty much security components and considerations, where they speak about, again, managing, a bit about virtualization and cloud security, and basic ASA UC inspection features, which is part of the, we're going to speak in here when we go to the modular policy framework of the ASA. And then about the option that you can configure on the ASA an access list, a single access list for both IPv4 and IPv6 restrictions, or you can control both the IPv4 and IPv6 traffic to the ASA by using a unified common access list. Now our course outline is going to be, I have divided the, let's say, the technologies in a different way. We're going to speak initially about control plane security, then about management plane security, then about data plane security, and then we're going to go to the ASA firewall and iOS firewall threat defense, and in the end speak about threat defense architectures. So pretty much this is going to be the order we're going to do things in class. Control plane security, we're going to speak about control plane policing, control plane protection, and routing protocol security. On the management plane security part, we're going to speak about telnet, SSH, role-based access control via AAA, network time protocol, syslog, CCNP version 3, and NetFlow. In the data plane security, we're going to speak about private VLANs, port security, STP security functions, DHCP snooping, dynamic ARP inspection, IP source guard, and unicast RPF or URPF. Most of them, we're going to also demonstrate them lively on the devices, but not all of them, because there's not enough time in class, even if it was 7 days, to actually prove everything on the CLI. And the most, let's say the most interesting, or the part probably which is going to be most interesting from your point of view, is going to be the ASA file threat defense, where we speak about all types of NATs on the ASA, access lists, deep packet inspection via modular policy framework, and the identity-based file, which means making rules on the ASA ACL rules based on users and groups, not based on IP addresses. And the AS file threat defense is going to be only the NAT configuration part, and of course the technology part, and the Cisco's implementation of stateful firewall on the iOS, which is the zone-based policy firewall, and likewise deep packet inspection also via zone-based policy firewall. In the threat defense architecture, we're going to speak about Cisco SecureX, what SecureX is, why Cisco came up with this, let's say, framework. We're going to speak about Cisco Safe, which is the security architecture for the enterprise. When we speak about a firewall design, so those modes, context, and about firewall management, which is going to be the Cisco Security Manager, SDM Cisco Configuration Professional, and Prime Security Manager in there. Okay, let's see if you have any questions in there. Okay, question from Matthew. Christian, what is the difference between configure and implement, please, as opposed to describe? Well, pretty much, I don't have an answer for that, to be honest. So from my point of view is when they speak about configure, clearly it means that you need to know how to configure that feature because you may get it on the, let's say, on the exam as a simulation. If they say implement, likewise, from my point of view, it means that you should also know how to configure it in there, which means how to configure it. So from my point of view, configure and implement should be pretty much the same thing. They just chose, for whatever reason, a different, let's say, naming convention, different wording, because both of them means to be able to configure that technology. Now, implement, I'm just thinking about it, implement may also assume that you also know how to troubleshoot it, possibly, because configure pretty much should mean that you also only need to know how to configure that technology, but implementation would mean that you need to know how to configure it, verify and troubleshoot it, for example, which clearly, as I said, describe in there means that technically speaking, per the exam, you should know just how to describe those features, so you don't expect Cisco to give you simulation questions for those technologies. But as I said it before, I highly recommend all of you out there to actually don't look at this blueprint like, for example, in the format of, okay, what do I need to know configuration wise, what do I need to know implementation wise, what do I need to know design wise. Just pick those technologies from there and just know them, understand them, know them, both to you, like what is the scope of the technology, how does it work, how do I configure it, how do I verify it, minimum. Because in the end, on the long run, it's going to help you tremendously in there. For example, to give you just a rough idea, like because I took this approach on technology learning from when I started, let's say back like 10 years ago, this let's say career, because I took this approach, I stayed in there on each technology till I mastered it. Okay, till I believe I mastered it, because in the end, after years of being more experienced and reading a lot more, I understood a lot more of that about the technology. But still, let's say that I took time to properly understand what I was reading by doing a lot of reading, a lot of video watching, and a lot of practicing and verification in there. So that helped me a lot because I built very few gaps only on the technologies which I misunderstood for a lot of reasons. But then, for example, when I started to prepare for my CCI exams, like running and switching and security, I needed only like 2 or 3 weeks of practice to get in shape with a good strategy, with, to get up to speed, and pretty much that was it. I didn't have to stay in there for 1 year or 2 years to learn, because I learned from the beginning the proper way. So I had no gaps. Because in a lot of my my CCIE classes, either on-site or online, of course, especially on-site, because I get to communicate back and forth with people better, I find out that they have a lot of, let's say, misconceptions and a lot of gaps that I have built throughout the years because of a wrong learning approach. So I highly recommend you, as I stated, take the blueprint just to understand what is the technology they're going to test you up on it, but just don't care about if they say configure or implement or describe. Just for each technology, you should know what is the scope, how does it work, how do I configure it, how do I verify it, minimum. Okay.